Welcome to video 4.6, our introduction to slope. So here you have two graphs, graph A and graph B. Just like what you saw in our GeoBoard activity, we're comparing two lines and we're looking at their steepness. So here you see, and this is what you're writing underneath, that graph B is steeper than graph A. And what we need now is vocabulary and way of measuring and comparing their relative steepness. And the way that we do that in mathematics is with something called slope. So slope is a measure of how steep a line is on a graph. So it tells us how rapidly it goes up or what the incline is. And we have a way of measuring slope or measuring steepness. And that's what we're going to be learning how to do here. So slope is equal to rise over run. So that's the formula, and I'll explain that formula in a moment. But what you need to write for now is slope is equal to rise over run. So rise has to do with how much the graph is going up or how much the line is going up. And run has to do with how much it's going over horizontally. So rise is how much the graph goes up, and run is how far it goes over. So another way of writing this is instead of slope, we use the variable m. So from this point forward in algebra, when we're talking about the variable m, we're often referring to slope. And so rise, we're asking how much the y increases, so the vertical change, over how much the x increases, the horizontal change. And the best way to understand this is just to do examples. So slope is rise over run, or m is how much the y increases. So y is our vertical axis, that's our rise, and x is our horizontal axis. So let's practice. Here I have a graph, and I've got 2 points on this graph. Now, this is very important. When you're measuring slope, you can use any 2 points on the graph. So long as the line is increasing at a constant rate, it doesn't matter if I'm going from here to here or here to here, the slope, the steepness doesn't change. And so I can use any 2 points. And so when you're measuring slope on a graph, you just want to find any 2 points where the line neatly intersects at an intersection of 2 coordinates. So you want somewhere where the line crosses evenly at an intersection. So here, if I want to know the slope of this graph, I want to know between point A and point B how much is the rise and how much is the run. So the rise, I'm just formatting. So the rise would be you see that it goes up 1, 2, 3 units. And then it goes over 1, 2, 3, 4, 5, 6. And so my run, my increase in the x, is 6. And so I'd write that m equals 3 over 6 because the graph goes up 3 units and then over 6 units. Now this can be simplified because we know that 3 over 6 simplifies to 1 over 2. And so I would say that the slope of this line is equal to 1/2. And that number, 1/2, is a measurement of how steep this graph is. Let's do another one. So here I'm looking at 2 points, and again, I ask myself, if I want to find slope, I need to look at the rise over the run. So this graph between point A and point B goes up 1, 2, 3, 4 units, and then it goes over 1, 2, 3, 4 units. And so my rise over run between these 2 points is 4 over 4. Now you know that 4 divided by 4 is just 1. And so here I would say that the slope of this graph is equal to 1. And that's why I measure, that's the number I use to describe its steepness. So we're going to do one more. If you look over here, you have something that's slightly different, but the formula doesn't change. So when you're reading slope on a graph, and this is very, very important, make note of it, write it down, and you're looking at how much did it rise, how much did it run, how much did it go up or down, how much did it go over, you always go left to right. So just like you read a book left to right, you read a sentence left to right, you read the points left to right, which means I have to start at this point up here. In the last 2 examples, I started with the point that was lower down, but that's not what was important. What was important was that I was starting at the point that was on the left, and then I was moving over to the point on the right. I started at the point on the left, moved to the point on the right. So here I'm starting at the point on the left, and I'm going to move to the point that's more on the right, which is down here. And so the rise is actually going to be negative because I don't go up, I end up going down vertically. And so my rise is actually -4 because I have to go down 1, 2, 3, 4 boxes. My run is +1 because I'm still moving in the positive direction horizontally. And so again, my rise is that I have to go down, so it's -1, 2, 3, 4 boxes. And my run is that I go to the right 1. So my slope here is -4 over 1. Anything divided by 1 is itself. And so this is just equal to -4. And so here the slope is -4. So some things to notice. The steepest line, if you look at these 3 graphs, the steepest line was this bottom one. That has the largest magnitude of number. So magnitude just means ignore positive or negative. So 4 is the largest magnitude, and that's the steepest slope. Half is the smallest magnitude, and that's the shallowest slope. Shallow is the opposite of steep. It means it's not very steep. Notice that the 2 positive slopes, the lines are going up, and the negative slope, the line is going down. And that's the last point I want to make. If you look at these graphs on the bottom, anytime you have a line that looks like it's increasing, I think of someone sort of walking up a ramp, they're going up. That's a positive slope. And anytime you have a line that looks like a downward escalator or someone going down a ramp, that is always going to be a negative slope. And so you can figure out if a slope is positive or negative mathematically by looking at if the rise is positive or negative. But you should also just be able to look visually and tell whether or not a slope is going to be positive or negative. And that wraps up our introduction to slope.